Hi, this is Mrs. Dubois, and this is a lesson on estimating square roots, and it builds upon a previous lesson. So we have talked about perfect squares, like 1 times 1, 2 times 2, 3 times 3. And then what's the square root? So the square root of 1 is 1. The square root of 4 is 2. So if we input a 9, to find the square root, the output would be 3. Now we're going to begin by taking a look at when things are not perfect squares. For example, look at number 1. The number 105 falls between which two perfect squares? Well, the number 105 falls somewhere right here between 81 and 100. And then if you look at the output, that is somewhere, then the square root of 105 falls between 9 and 10. Okay, so for number 2, we're going to examine the input and the output, taking a look at our table. The number 7 falls between which two perfect squares? Well, the number 7 falls between 4 and 9, which means that the square root of 7 falls between which two integers? 2 and 3. And notice that's our output, 2 and 3. Example 3, the number 42 falls between which two perfect squares? Again, we're going to look at our input, and 42 falls between 36 and 49. So 36 and 49. Then the square root of 42, so you're looking at the output, falls between what two integers? 6 and 7. Then the number 91 falls between which two perfect squares? So 91 falls between 81 and 100. And if you look at the output, the square root of 91 falls between 9 and 10. I'm just looking for what two integers in that section. You're just looking for what two integers does the perfect square fall between. All right, if you look at part 2, we're going to draw perfect squares. So all these numbers up here, 1, 4, 9, 16, 25, 36, etc., they all, this is kind of where geometry and algebra collide. If I were to draw all these perfect squares, like we're about to do, you will see that they form a perfect square. So, part 2, follow the directions to lead to estimating the square root to a decimal. Okay, so draw a square using 16 blocks. So that's a 4. Now remember, a square means that the sides, each side is the same. All 4 sides have the same measure, okay? So if you notice, this gives me 16 blocks, and the square root is 4, because 4 times 4 is 16. If I move to 25, that would be a 5 by 5. Again, a square has to have the same measure on all sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so this is a 5 by 5. Okay. So the square root is 5. 5 times 5 equals 25. Now, can we draw a perfect square that is 18 blocks? And remember, a square, by definition, has the same measure on all sides. Okay, and we cannot draw a perfect square with 18 blocks. So the answer is no. What is 18 closest to, 16 or 25? Well, it's closest to 16. So let's estimate the square root. Well, the square root of 16 is 4. So it comes between the integers 4 and 5, and it's closer to 16. So we're going to estimate to 4.2. Now your answer might be a little different, like 4.3, which is completely fine because we're estimating. You just don't want a number like 4.9 because 16 is closer to 18 than it is to 25. All right, can we draw 36, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, this is our square. It's a 6 by 6. The square root of 36 is 6. Is 49. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. You get a 7 by 7. And the square root of 49 is 7. And I can make, it's a perfect square because geometrically I can draw a perfect square. Now, can you draw a perfect square with 44 blocks? No. And 44 falls between, right? Square root of 36 and the square root of 49. Now, is 40 closer to 36 or 49? Well, it's closer to 36. Oops. Oh, that should be 40. Whoops, sorry about that. 40 is closer to 36. So we can estimate, and again, it's an estimate. The square root of 6 is 6. So like 6.3. Okay. Now, can we draw a block with 4? That's 2 by 2. So the square root of 4 is 2. This is a 3. To get 9 is a 3 by 3. Square root of 9 is 3. Can you draw a perfect square with 8 blocks? No. So if I'm looking for the square root of 8, it falls between the square root of 4 and the square root of 9, which is 2 and 3. 8 is much closer to 9. So we're going to have a number very close to 3 when we estimate. And again, you might have, I'm going to put 2.9, but you may have had 2.8, which is completely fine. Now let's estimate a few. And remember, your answers will vary, may vary. How's that? Because we're estimating. So the square root of 37 comes between the square root of 36 and the square root of 49. And it's closer. So I would estimate it to be about 6.1 because it's really close to 36. If we're looking at 118, it's between 100 and 121. And it's closer to 121. So I'm going to put like 10.6. Could have 10.7, something that's greater than 10.5. 130 falls between, sorry about that, falls between the square root of 121, right? And 144, which is falling between 11 and 12. And 130 is closest to 121. So I'm estimating again 11.3. Might say 11.4. And then the square root of 12 falls between 9 and 16, which means the square root falls between 3 and 4. 12 is closer to 9 by a tad, huh? So like 3.4, something less than 3.5 is good. And then the square root of 52 is coming between 49 and 64. So that's somewhere between 7 and 8. And so 49 is closer to 50, 52 is closer to 49. So I'm going to do 7.3. All right, and again, these are estimations. So as long as your decimal is close, you're in the right ballpark. Thank you.